All right, welcome back to another video. So today we're going to cover how to do systems of equations. So in our past videos that we've done so far, we've gone over all the skills you will need up to this point to be able to do systems of equations. And systems of equations are not bad if you understand all those topics that I've gone over so far. So if you have not gone over those topics yet, or you're not really good with those topics, try to rewatch those videos and stuff before you start this video, because this video is going to build on all of those skills. So let's get straight into it. Let's start with defining what are systems of equations. So the answer is that systems of equations are just when you have multiple equations, and you're trying to solve for a variable. Oh, that was bad. Okay. So you're solving for a variable or maybe some variables. So that's what we do when we have systems of equations. We're solving to try to figure out, when we're given two equations, how can I solve for a specific variable, at which point those two equations would intersect. So the first best way to actually understand how systems of equations work is to actually look at how we could solve one by graphing. So here I'm given two equations. I'm given the first equation, y is equal to 3x minus 4, and my second equation, which is y is equal to negative 1/2 x plus 3. So now we have to actually figure out, how can I graph this and figure out where do both of these equations intersect at some point where we know that they are equal to each other. So the way we do this is we solve by actually just graphing both of these equations. So let's start with the first equation. I'm going to highlight this in red, and I will get a red color right now. So if you remember from my previous videos, or maybe you've learned this in pre-algebra, it's very simple. You start off by looking, when you're graphing, you look at your y-intercept. So that'd be -4. So you start off at -4. And then we have a slope right here, which again is the rise over run. So our slope is 3 over 1. So therefore, that means I'm going up 3 and over 1 each time that I'm getting a new point. So I'm going from this -4, I'm going up 1, 2, 3 over 1. So again, 1, 2, 3 over 1. That's what we're doing. So we put that point right there. Let's do another point just to be safe. We'll go up 1, 2, 3 over 1, like that. There we go. And now we're just going to take a nice line and we're going to draw it straight through. And that's pretty much how we do it. So now our next thing is to do the next equation. So we graph our new equation now. So -1/2 x plus 3 is equal to y. So I get my blue color, and let's go. So we have, again, a y-intercept of +3. So now we're going to go over here to +3. And then our rise over run is -1 over 2. So that means I'm going down 1 and then over 2. So I'm going down 1 over 1, 2. So we're starting over here. And then we go again down 1 over 1, 2. And we have a nice line. So I'm just going to draw a line straight through that now. So we can oh, move this over. So this is what our line should look like. And the thing we can notice is that the red line and the blue line are intersecting at one point. And that one point is going to be right over here, as you can see. So that point where we intersect both lines, that is showing our solution to the systems of equations. So essentially what we're saying is, at this point, which is, I believe, 2, 2, at 2, 2, where x is equal to 2 and y is equal to 2, both of these equations intersect, and the value 2, 2 works for both of these equations together to solve them. And that is all we're doing. So we're just trying to find, with the systems of equations, we're trying to figure out what coordinate point could I plug into both of these equations to make the equations equal and be correct, I guess. So now we know that the solution would be 2, 2, and we solve that using graphing. So that wasn't too bad. So again, you're just graphing, not too bad. So now let's look at our next one. Our next one is going to be substitution. So when we do solution by substitution, all we're trying to do is we're trying to figure out, okay, the same exact idea. What coordinate could I put into both of these equations right here to get me to have the equations be equal? So the best way to do it with substitution is to take one variable and make it and put it into another variable. So let's see what that looks like over here. So we see over here we have y is equal to 6x minus 11, and then negative 2x minus 3y is equal to negative 7. So all we're going to do for this is we're going to try to figure out, okay, so if I plugged in, let's think about it for a second. So we have in this equation right here, we have what? We have negative 2x and negative 3y is equal to negative 7. And then this one, this gives me y's already solved. So if you think about it, wouldn't it be kind of cool if I could just take this y value right here and plug it into there? Because if you think about it, this y is equal to 6x minus 11. So if I plugged in the 6x minus 11 into here, I should be able to solve and it should be able to work out. So let's try right now. So again, we're trying to plug in this y value. So the y value is equal to 6 minus 11. We're plugging it into there because the y's are equal to each other in this case, right? So let's work this out now and see how we do this. So we'll take our equation right here, the negative 2x minus 3, and it's minus 3y, right? So watch how we do this, right? We're multiplying negative 3 times y. So instead of putting a y here, we're going to instead put a parentheses and then put in this stuff because this is equal to y. 6x minus 11 is equal to y. So instead of putting what y would normally be over here, I'm instead going to put that 6x minus 11. So 6x minus 11. And then this is going to all equal to negative 7. Not too bad at all. So now we just have to simplify like we do with a normal linear equation. And this, if you've watched the previous videos, this should not be too hard. So it would be negative 2x minus 3 times 6, which is negative 18x, plus 33 is equal to negative 7. So therefore, negative 2x minus 18x is negative 20x plus 33, and that's equal to negative 7. And you can just subtract the 33, and that'd be negative 40, and that's equal to negative 20x. Then you just divide the negative 20 on both sides, and therefore x should be equal to 2. So now we've solved for x, but we have not finished yet because now we have to solve for y. So now that I know what my x is, I can just plug this x back over here into here where it says that because we already have y simplified on that side. So let's do it. So now we're going to take this y is equal to 6x minus 11. So y is equal to 6, but instead of just having x, we're instead going to plug in this value because x is equal to 2. So we just plug in 2 for that, and then minus 11 as for the rest of the equation. So therefore, 6 times 2 is 12 minus 11, which is 1. So therefore, we know that y is equal to 1. And therefore, you've solved for x is 2 and y is 1. That is your solution to the equation. So again, with substitution, all you're trying to do is if you have one variable, this keeps going, okay. So if you have one variable isolated on this side, or on any side, if you have one variable isolated in general, then you could just take it and plug it in to the other equation, and then you could solve. So it's not too bad, very, very straightforward. So let's do one more, and then we'll do some of the try it problems for you guys. So let's look. You have solving by elimination. So with elimination, we're doing the same exact idea as we were doing with substitution and the graphing. We're trying to find some point at which both of these equations intersect and at which they would both be equal to each other and they would both come out to be correct. So let's look at how we do elimination. So with elimination, all we're doing is we're trying to take we have two equations and we're trying to eliminate one of the variables in those equations. And by doing so, we can isolate for just one equation. And sorry, we can just isolate for one variable. So let's look at this. We have solving by elimination for this one. So we want to make one of the variables eliminate and be completely gone, so we'd have just one variable isolated. That's what we're always trying to do. With substitution, we were doing the same exact thing. We plugged in this 6x minus 11 over here into here, so we would only have an x, right? There's no y's in this equation. It was just an x. So it's the same exact idea over here, but just a different method. So we're going to solve by elimination by eliminating something. So what we do when we're trying to do this is we add up both of the equations together. So I'm going to add up 4x. So when I do this, we're going to be adding up all of these. Okay. So here's what it looks like. So when I'm adding, it's like normal, but you can only combine the like terms as you're going down. So as we can see, 4x, positive 4x minus 4x, this positive 4x minus 4x, that's going to equal to 0x, so it would just cancel out. So this already was solved for us. That leaves us with 8y plus 2y, which is 10y, and then 20 minus 30, which is negative 10. So therefore, divide the 10, y is equal to negative 1. And that is all we do. Not too bad. But one thing I'm going to say is that sometimes you're going to be given some kind of elimination problem to do, and it's not this easy. It's not this easy to just isolate the variables because they cancel out. So when that happens, you may have to actually cancel out the variables by multiplying one of the sides. So for example, um, I'll do that. I'll do this in a minute. Actually, let's finish this problem first, and then we'll do that. So we've solved for y is equal to negative 1. So now the next thing we want to do is plug this y is equal to negative 1 back into one of these equations over here. Either one is fine. You plug it back in, and then you would be able to get what x is equal to. And then we would have the entire system solved. So for example, let's assume we were given, so we have this y is equal to negative 1. So now we're going to plug this in to, let's say, the first equation. So we'll take this equation right here. 4x plus 8y is equal to 20. So we know that y is equal to negative 1. So we'll just plug in that negative 1 when we get to y in this thing. So we get 4x plus 8 times y, which is negative 1, equal to 20. So 4x minus 8 is 20. You can add an 8. 28 is equal to 4x. Therefore, x is equal to 7. Right? So now we know the answer to this equation would be 7 comma negative 1. That is all you do. So as I was saying, it may not be this easy to do in the future. So in this kind of scenario, you may have to actually multiply one of the coefficients so they could cancel out perfectly. So let's say instead of 4x plus ay is equal to 20, for this first equation, they gave us 2x plus 8y is equal to, oh, sorry, no, they would give us 2x plus 4y is equal to, let's see, it's equal to 10. And then they gave us negative 4x plus 2y is equal to negative 30. So how would I solve this? Because now we want to do the elimination method, but we cannot cancel anything right now. So the way we do this is we would just find a way to multiply the coefficients so that one of the coefficients would cancel out. So let's look at this. We could take this entire first equation and multiply it times 2. By doing so, we'd be able to cancel out the coefficients of this and this. Because if you think about it, what happens when we do that? We would get 4x plus 8y is equal to 20 because I've multiplied everything in that first equation times 2, and then the next one would be negative 4x plus 2y is equal to negative 30. Cancel it out, and you'd get 10y is equal to negative 10, so y is equal to negative 1. Very, very simple. Shouldn't be too bad. It gave you the same exact method, but that's just in some kind of scenario, like I think in the try it problems, I put one of those where you're going to have to multiply the coefficients. And that takes practice if you're struggling with it right now. It takes practice, so keep doing multiple practices like this, and it should help you. So now that I've gone over the 3 basic methods, now I want you to pause the video, try some of these problems right here, and come back in a moment and we'll go over them. All right, so I hope you went over them. So now I'm going to actually teach you guys, and we're going to check and see if you were right. So let's look at number 1, solving by graphing. So the same exact idea as before in the previous problem I did with the graphing. So we're going to graph these like I've taught you guys how to do, and then we are going to see at what point both of these equations intersect. So let's begin with the first one. The first equation says, the first equation we have right here says that y is equal to 1/3 x minus 3. So we start off with our y-intercept, negative 3, and then our rise over run is 1 over 3. So we go up 1 over 1, 2, 3, up 1 over 1, 2, 3, up 1 over 1, 2, 3. So it's off the board. Okay. And then down 1, 1, 2, 3. There we go. Okay. So I have this right here. There we go. And then our next equation that we're given is this y is equal to negative x plus 1. So we again begin with the y-intercept, which is 1. And then we're going to go down 1 over 1. Because it's, if you think about it, negative 1 over 1 is our rise over run. So we're going to go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And that should be enough. So I'm really bad at drawing lines on the iPad. Here, this should be better. Okay. So what do we notice right here? We notice that both, okay, I drew the purple line kind of bad, but we do know that they both intersect right at this point, as we can see, right here, right? This point right here is where they intersect. So therefore, the answer to this problem was 3 comma negative 2. That was our solution because they intersect at that point. Very simple. Just try it out. If you didn't get it, just make sure you're trying to make sure where you can find where they intersect. Our next problem is solved by substitution. So I'm actually going to, see, I'm going to actually bring this down so I could actually have more room to work. Here we go. Okay, so let's solve this by substitution. So when we're solving by substitution, we have to remember we're trying to get one variable isolated onto one side so we could plug it into the other equation. So by looking at this, I could see that the first equation that they give me is easier to isolate. So I could just, I take this x plus 3y is equal to 1, and I subtract my 3y on both sides. And by doing so, this leaves me with x is equal to negative 3y plus 1. So the x is isolated now because I just did that, and then x is equal to this amount. And that's all we're doing. So we just have to plug that in now to the next equation, and we could solve. We could start to solve. So in this one, we have negative 3 times negative 3y plus 1, because this was equal to x, and x is equal to this. And we're going to add our 3y, that's equal to 1. Then we can multiply it, so it becomes 9y minus 3 plus 3y is equal to 1. And then I hope I don't run out of room. Okay, so if we simplify this, it becomes 12y minus 3 is equal to 1. And I'm going to bring this over here so I can finish it. Right, so we'd add our 3. So 4 is equal to 12y. And then y is equal to 1/3 when we simplify that. So that's not too bad. And then now that we know that y is equal to 1/3, now we can just plug in the 1/3 into the first equation again, or the second equation. Either way, it works. We plug in that 1/3 into one of these equations, and we can solve for x. So since I've already isolated for x right over here, I'm just going to plug into that. So let's go. We have x is equal to negative 3 times 1/3, because that's 1/3 is equal to y. We'll add 1. So now that I've done that, now I can actually figure out how to get x, because I just do x is equal to negative 3 times 1/3, which is equal to negative 1 plus 1. So x would be equal to 0. And that's our answer, 0 comma 1/3. That is our answer to the substitution equation. Not too bad at all. We have one more problem. We have to solve this one by elimination. So as I taught you guys in the past one, you have to spot something like this. So clearly we cannot eliminate something because none of the variables cancel out at the very beginning. So we have to make it so that one of the variables can cancel out. So what I generally like to look for is I try to make it so that I can figure out if anything could easily cancel out if I multiply. So let's look. Okay, so we have 5x and we have 10x. So I'm going to multiply this first equation times negative 2. Because if I multiply this negative 2 times 5x, this becomes negative 10x, right? This turns into negative 10x. And negative 10x plus positive 10x would cancel out and become 0, leaving me with just this part. So we're going to try that right now. So we're going to distribute. So it becomes negative 10x minus 2y is equal to negative 18. And then positive 10x minus 7y equal to negative 18. So I multiplied this negative 2 times everything inside of here. And then that helped me right over here. So like that. Then we have negative 9y is equal to negative 18 minus negative 18, which is negative 36. And then y should equal to 4. And then now I just want to solve for my x, as I always do. So I could plug in this y is equal to 4 into any of the equations that I was given originally. So let's take our first equation. We had 5x plus y is equal to 9. So let's plug in the y is equal to 4 in there. So 5x plus 4 is equal to 9. So we subtract the 4. 5x is equal to 5, and x is equal to 1. And there we go. We have solved the, oh, I don't know what happened there. Okay, so now we have solved 1 comma 4 as the solution to this equation. So I hope this was helpful. If you have any questions or comments, leave it in the description down below, and I'll get to that as soon as possible. Thank you.